This is worksheet 3 of the atomic structure packet, and this is the second part. So at this point you should have already watched the video for part 1 that taught you how to write electron configurations, and hopefully you have practiced writing some electron configurations in class. And if you have, you've probably noticed that as you get further along in the periodic table and the atomic numbers of the atoms get larger, the electron configurations get really long and really tedious and pretty annoying to write. So the good news is that there's a system for abbreviating, and you will be expected to know how to abbreviate electron configurations. So what you need to remember is that the very last column or family of the periodic table are called the noble gases. And the noble gases are really, really stable, okay? And we've said that before, but now you might start to appreciate that every time you write an electron configuration for a noble gas, the electron configuration of a noble gas ends with 2 electrons in the final s orbital, whether it's 2s or 3s or 4s, okay, and that's the maximum that an s orbital can hold. And it ends with 6 electrons in the p orbitals, p, x, y, and z together, which is the maximum number of electrons that can fit in the p orbitals for levels. So whether it ends in 2p or 3p or 4p, they're full. Okay, and that's what makes these noble gases so stable, is that their outermost s and p orbitals are full. S with 2 electrons in it, p with 6 in it, giving you a total of 8, right? The 2 and the 6. So you have 8 really stable, fully filled electrons in these outermost shells, and that's actually what we call the octet rule, octa being a prefix for 8. Okay, fine. So that's why noble gases are a big deal. And so what we're going to do is, if we want to write the electron configuration for an element, we're going to try to figure out what was the noble gas that came most recently before that element. And we're going to compare the electron configuration of the element that we're trying to abbreviate to the noble gas that comes before it. Because the noble gases are kind of like our reference elements. So if we use the example of chlorine, I've filled in chlorine and some of the noble gases on our periodic table for reference here. Okay, if you were to look at your periodic table, you'd see that chlorine is element 17. All right, that's its atomic number. So what you want to do is you want to look at the atomic numbers, and you're going to have to do this on your own periodic table since it's not written on these, but you want to look at the atomic numbers of all the noble gases, helium, neon, argon, so on and so forth, and see what's the noble gas that comes just before chlorine, element 17. Okay, and it turns out it's neon, right? Neon has an atomic number of 10. Okay, now you might think it was argon because argon is the closest to chlorine, but argon is element 18, so it actually comes after chlorine, so that doesn't work. You got to pick the one that comes before it. All right, so what we're going to do when we go to write the electron configuration of chlorine is, we're going to write that its mass is 35 and its atomic number is 17. You can get those off the periodic table. We're going to write a little Cl. And then what we're going to do, instead of starting way over here with hydrogen and writing 1s2 and then 2s2 and 2p6, and which you've written a million times now, right? It's like a broken record. What you're going to do is you're going to say here, let's skip to the closest noble gas we can get to on our way to chlorine. We're going to write neon in brackets. And that's like a skip a whole bunch of spaces free card on our board game here. What that means is instead of starting way over here at hydrogen, you actually get to start at neon. Okay, so neon's element 10. What you're going to do is you're going to go over to element 11, over here, which will be sodium, and that's where you're going to start building your electron configuration. So you're going to say, okay, I'm in the 3rd row of the S block, and I've got these 2 elements that are in the 3rd row of the S block. And now, just like before, I'll go over here, and now I'm in the 3p section of the periodic table, third row, P block. And to get to chlorine, I'm going to go through 1, 2, 3, 4, 5 elements that are all in that 3p section. Okay, so you just saved yourself the trouble of writing 1s2, 2s2, and 2p6, because that's what this means. When you put neon in brackets, it means, okay, plug in neon's whole electron configuration and then add on to it this one part that's different for chlorine in addition. Okay, so we could practice another one. Okay, let's pick this time, just for fun, we'll pick germanium, GE right here. Okay, so germanium, if you look at your periodic table, 73 is its mass, if I round it, and 32. Okay, 32 electrons, that's a lot of electrons. This would be a pain in the butt to write the whole electron configuration. Okay, so if its atomic number is 32, then the noble gas that comes before it, most closely, is argon, element 18. Okay, I know it's closest to krypton, but krypton's element 36. That's beyond germanium. Okay, so I'm going to put argon in brackets, which means skip all the way to argon. So you skipped 1s2, 2s2, 2p6, 3s2, and 3p6. You just skipped a whole bunch. Here's argon. It's element 18. So you're going to go over to element 19, which is actually potassium. You're going to say, okay, now I'm in the fourth row, S block, and I've got two elements, potassium and calcium, as it turns out, okay, that are in this section. Then I move over here to my D block. Okay, now remember, I'm in the fourth row, but the D block sits one behind. So instead of calling this 4D, which would be tempting to do, we got to call it 3D. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, whoa, 10 elements that are all in that 3D section of the periodic table. Okay, we move out of the weird off by one number d orbitals, and we get back into the p orbitals. And now we're going to call this 4p, because it's the fourth row. And we go through 1, 2 elements to get to germanium. Alright, so that's the abbreviated electron configuration. So there are a couple of questions that I think you should be able to answer. You might have to go through and rewatch some of this or reread a little bit, but I want you to try to answer these, and then we will practice writing some abbreviated electron configurations together in class.